This is going to be the video set of notes for CCNA 2, Chapter 5, Switch Configuration. This chapter will contain a lot of commands that we have to enter in for switch configuration. A lot of them we've already learned, a couple new ones that have to do with switch port security, changing your switch port to an access mode, and things of that nature. Other than that, there will be commands that we've seen like message of the day, securing your VTY, your console lines, all that kind of stuff. So there will be a bit of review here as well. Chapter 6 is when things get really interesting and everything's completely new again, pretty much. So enjoy your last somewhat easier chapter for a little bit here. We've had a streak of a few easy chapters, actually, it seems like. So here we go. First thing we come into, well, the overview. Configuring initial settings on a switch, that'll be review. Switch security and how to implement that, that's going to be a little bit of the new stuff, but there's really not that much there. Basically, you're going to be protecting your switch ports from MAC address flooding, and you can see how that's going to work as we get later on into the chapter. Moving right along. The switch boot sequence, you're going to want to know that that's definitely test question material. So we have our power on self-test, basically just checking the hardware to see that it's functioning, your CPU, your flash, your DRAM. Then you are going to, step 2, run the bootloader software. Okay, that bootloader software is going to perform low-level CPU initialization, initializing your CPU registers, where the which controls where the physical memory is mapped, quantity of memory and its speed. Bootloader is going to initialize the flash file system, then it's going to locate and load the iOS into memory and passes control of the OS, passes control of the switch over to iOS. So that's your boot sequence. We'll take a look at a little bit more here. Next slide. Alright, so to find the iOS image, the switch is going to go through the following steps. First, it's going to try to boot using the information, the boot environment variable, which can be set with this boot system command down here. Basically telling the switch where to look for the iOS. Is it going to be in flash? Are you looking at a TFTP server? Are you going to be using a memory stick or a flash drive? Where is it at? If that variable is not set, it's going to do a top-to-bottom search through the flash file system, and it loads and locates the first file it can. After the iOS is loaded, then it's going to look for that startup configuration file that we've saved to NVRAM many times to load the startup config, and if it's not there, it'll go through an automatic startup process. So that's going to be your entire boot process. If everything's working correctly. If you have crashed, there are some things you can do as well. So if you need to recover from a system crash, basic steps are here. You're going to basically console in and unplug your power cord on the switch. Okay, reconnect the power cord to the switch while pressing and holding the mode button. So as you do that, you'll see some lights flash. The LED briefly turns briefly amber, then a solid green. You'll release the mode button, and at that point in your console session, you'll see the prompt switch : appear, which lets you know that you're in to the bootloader. Once you're in the bootloader, you can reinstall the operating system software. You can format the flash file system. You can recover a lost or forgotten password. So there are some steps you can use to make the switch operational again once you're in that prompt. We're not going to get into those steps at this part of the course, but that's how you would get into the bootloader to configure and recover the switch from a crash. Okay, you're going to want to know a little bit about your switch LED indicators. Well, really a lot if you're dealing with them, but for the test materials, you're just going to need really to know about the duplex and speed indicators and what those colors mean. Now, first of all, you do have indicators for each port on your switch, okay, labeled above. All right. You have some different things that those port LEDs can mean based on the mode that you're in here. You have basically a light that'll show up here. And you can press this mode button to cycle through your different options off to the left, your redundant power system, your port status, your port duplex LED, port speed, and power over Ethernet. Okay, so depending on which one of these is lit up, that is going to determine what the light flashing up here means. Okay, and the ones we're going to concentrate on are duplex and speed. So if you've pushed mode to the point where duplex is selected, basically when you have a LED that's off with duplex selected, that means the port is in half duplex mode. Okay, if the LED is green, that means that you're in full duplex mode. Okay, and for port speed, so if you press mode again, it drops down to speed. Port speed, if that's off, then you're at a 10 megabit per second speed. If the light is green, then you're at 100 megabit per second speed, and if it's flashing green, then you're at gigabit speed or 1000 megabit per second speed. So you're going to want to remember that. Those things can come up in tests. Prepping for basic switch management. We've already done most of this, in fact all of this, to remotely manage a switch. We've set up our VLAN, we've set up a IP address on that VLAN, we have done Telnet, we've done SSH, we've given the switch a default gateway. So those are all things you'll need to do, well, not the Telnet SSH part, but on the switch itself, you're going to need to provide an IP address subnet mask gateway to the switch virtual interface. Default gateway being assigned in global config mode, not in the not in the VLAN line configuration. What else? We got a default gateway. We do that, and of course, setting that IP address up does not allow the switch to perform as a layer 3 device. Even if it's a layer 3 switch, those commands themselves do not allow the layer 3 switch to perform as a layer 3 device. You actually have to type in a few other commands to make that happen. So here are commands that we've used before, getting into global config. You see that they've switched us to VLAN 99 to use for our management interface. We've been using VLAN 1. Doesn't matter which VLAN you use. In the end, you probably won't end up using VLAN 1 or 99 for managing your switch. You'll use some random number just for security purposes, so someone doesn't just guess, okay, normal configuration calls for 99 or 1, so maybe that's how you get into manage the switch, and they try to mess with your device. So next chapter it'll become more clear why we'd use a different VLAN, but it's basically for security purposes. So in this example, I know we've been using VLAN 1, but they're using VLAN 99, which is fine. That is fine. They give it an IP address, subnet mask, no shutdown to bring it up, and end. They'd probably also want to type in IP default gateway if there was a default gateway to access to manage that switch remotely. And there it is, actually, global config. So there's the IP default gateway that you'd want to type in. And here's our show IP interface brief to confirm that everything went okay. Our management interface is up, and you can see that status there. We've talked about half duplex versus full duplex. You can either send or receive with half duplex or do both at the same time with a full duplex setup. You can set that up on your switch interfaces manually. The default is for automatic configuration, okay? But we can also set this up manually. So you've got a couple different things you can do here. Duplex and speed. If you got interface, fast Ethernet, yada yada to get into your interface. Duplex, full, auto, or half, depending on what you want there. Your speed, typically 10 100, or 1,000, depending on how much speed you want. That speed is, of course, the number you type in is in megabits per second. Okay, and really not too much there. Those are the only two commands that you need for, of course, duplex and speed. So know those commands. We'll be using those in labs in class. Auto-MDIX is a concept we discussed as well. It eliminates the need to worry about straight through versus crossover cables. It'll automatically make sure that your pins on your port line up so you can send and receive no matter what type of cable you're using. Okay, Auto-MDIX, it is something that is available on your 2960 switches that we use in class, that hopefully you'll be using out there in the real world. If you have something like a 2950 switch, a Auto-MDIX is not a feature that is accessible. For your labs and for your tests, definitely don't assume that Auto-MDIX is on. In fact, it won't be on 99% of the time. They'll want you to use the correct cable, be it straight through or crossover or whatever, as you're connecting different devices. So don't ever assume that you don't need to worry about your cabling in testing situations, because you definitely need to use the right cabling in testing situations. So here we have a command to turn on Auto-MDIX, which is just when you're in the interface that you want to turn it on. You type in MDIX auto and that'll turn it on. It's automatically turned on if you got a 2960 or a 3560 switch. It is not available again in the 2950 or the 3550 switches. So if it's basically supported by the switch, it's on by default. You can verify it there. Show controllers, Ethernet controller for whichever interface, include Auto-MDIX, that'll confirm it. So a little bit of a long command. You don't have to, well, type it all out. You could use the shorthand version, but it is still a pretty long command. Okay, and by shorthand I just mean abbreviating and stuff, like we've done in class. Our different show commands: show flash, show running config, show interfaces, show history of commands. We've seen all of these. So yeah, those are our show commands that we've used, displayed again for you. Always important. Alright, so if you've got issues, you can do your show interface for a certain interface and kind of deduce what those issues might be. So we've got a few issues here. We've got some collisions happening, we've got some late collisions. You can see that there are sections for runts and giants, things of that nature. We've gone over runts and giants. Runts are frames that are below the maximum size. Okay, lower than 64 bytes in size, and those are usually as a result of collisions. Okay, we don't have any here, and also giants are larger than the maximum size for your frame. So I believe that maximum size is 15, 18, or 22. I can't recall off the top of my head. It's 15 something. So we have none of those there. We have 3 CRC errors. Okay, a CRC error, or a cyclical redundancy check error, means the frame doesn't match its CRC value. So there's something that happened to the frame during transmission. That could be because of media or cabling issues, too much noise on the network, too much interference. So that's where the CRC issue could come in. If you've got collisions, you're probably operating in a half duplex environment. So that's why you might have collisions there. You've got late collisions, which can be caused by excessive cable length. So if you see late collisions, that's probably the issue there. So you'll need to know how to read these and kind of determine what the issue could be depending on what type of error you get. So there's that. Runts due to collision, CRC due to interference or a media issue, cabling issue. Collisions due to half duplex, late collisions due to an extensive cable run, once again. All right, and here's those errors that show up in just a list of them. It was 1518. Okay, so that's good. And I'll leave that there for a second for you to read. And I'm not going to read it. So, let's move on. It is in your readings as well, so you can check it out there. And the last thing we have for this section of Chapter 5 is troubleshooting network access layer issues. You could do your show interface. Is the interface up? If it's yes, then you can see if there's any EMI, any noise, any cabling issues. Not damaged cables that would be going over here. You can also verify duplex settings, see if that's properly set. Okay. If the interface isn't up, you can check the cables, make sure they're not loose or damaged. Verify that the speed is set properly on both ends. Okay. And then move on to the next step. Is the problem solved? No. Well, I don't know what to do. I'm just going to escalate it, I guess. If it is solved, then great. We discussed on the previous slides what these errors can mean and what you might want to check out there in terms of troubleshooting. Okay, so I guess cabling can be cause you to have your interface down, but cabling can also be the reason you have CRC issues as well. As far as cabling, maybe that's too close to electromagnetic interference. Maybe your cable's not twisted well enough. So it applies in both places. And we have our next section here. In this section we have switch security management and implementation. We are basically going to go through securing your switches so that you're only allowing the MAC addresses you'd like to communicate over the switch, as well as going over SSH again, basically. So there's only really two concepts here, but the securing the MAC addresses is a little lengthy, but not too bad. So we'll go ahead and move to the next slide. We have SSH, which we have configured in class already. We use SSH because it has encryption and it sends all commands and data over the SSH connection using encryption rather than plain text, which Telnet does. So it is a lot more secure than Telnet. You can see that SSH uses port 22, Telnet uses port 23, maybe test questions. So you've got that there as well. What else? That's pretty much it. We've configured this before. And the way we did is we had to do you had to create a username, we had to create a domain, and things of that nature. So you can see the commands that we entered in before here. Of course, we're in global config, IP domain name, give it any domain name. It doesn't need to be something.com, just any domain will do. Okay. Then we typed in crypto key generate RSA because that's what packet tracer will accept, and it works fine in real life as well. But you could also in real life type in modulus, and then the number you want here, how many bits in the modulus, 512, 1024, up to 2048. So you could do that, or actually it goes up to 3060 something. But you can do it this way like we would in packet tracer, or you could write out modulus and the number out there as well in a real life situation. Might as well get used to this because this is what works in class. So you type this in, enter, it asks you how many bits. 1024 is what we typically use. Also for SSH, you're going to need to use a username and some password for that username to log into your SSH section, which we did in CCNA 1, so this all should be review. Then you're going to go into your VTY lines, transport input SSH, login local. Okay. If you want to use SSH version 2 from global config, you type in IP SSH version 2. And those are all the commands you'll need to configure SSH on a switch. This is something that may come up in the test. There are a few packet tracer questions on this chapter's test, so they want to know this process pretty well. Okay. Verifying SSH, you can go ahead and use PuTTY to connect in. You'll have to use your password and whatnot to set up that SSH session, I should say. You can verify by doing a show SSH on the switch, and you'll see SSH enabled, which version, version 2, authentication timeout, how many bits is the key, 1024, so on and so forth. So you can also show SSH down here. Alright, so those are two different ways to show SSH, and make sure that it's up and running. Alright, so that's about it there, I believe. Yep. Alright, secure unused ports is another thing we do for port security. You don't, if your switch especially isn't just some place where anyone can plug in, you might have somebody trying to just plug into the switch and get into your network by accessing the physical device. If you don't or want to prevent that from happening, one measure you can take is to shut down any unused interfaces. So what the text recommends us do, and which is a decent practice, is to go into your interfaces that aren't being used and just shut them down. Okay. Instead of doing a no shutdown command from an interface, you would just do a shutdown command, and that interface would be shut down on your switch. Remember that your interfaces on your switch will automatically go into an up state if something is plugged in. Okay. Otherwise, you have to shut them down yourself if you don't want them to go into an up state when a device is plugged into the switch. Okay. So that's something you do, is just use the shutdown command to disable unused ports. You only want to allow the MAC addresses of legitimate devices onto your switch and onto your network. And one way we can do this is through port security that allows us to limit the number of MAC addresses that can access a port. And if a violation occurs, if there are MAC addresses above the allowed amount, then you can, well, do a couple different things. You can make the switch disable itself. You can, the switch port, I should say, you can make that switch port disable itself. You can make just deny access to the device, or deny access to the device and report that a device tried to access the switch at the same time. I'm probably getting a little bit ahead of myself. That's going to come up in the next slide or two. Okay, so what we have here is this switch port security command, and well, the slides kind of aren't in the best order here. Switch port security does enable the feature which will limit the number of MAC addresses that can be assigned to each port. Okay. By default, if you just enable switch port security, you're only allowed one MAC address on that port. So you can set that up a couple different ways. That MAC address you want on the port, you can manually add it. Okay. So if you do switch port security MAC address and then type in the MAC address that you want, that's the only MAC address that will be allowed on that port. Okay. And that MAC address that you type in with this command, switch port security MAC-address, and then the MAC address you want, that's going to be added to your running config. And if you, of course, copy your running config to startup config, that's something that will be saved to the startup config. So that will be remembered next time the switch reboots. That can be an issue if you decide that you, well, want to plug a different device into that port. You're going to have to go in and wipe that out and type in another switch's MAC address or another device's MAC address. Okay, that's all well and good if you are the same network administrator that set this up initially, but it could be frustrating for someone else who comes in and is wondering why the device they're plugging into the switch isn't working. It would be because this MAC address has been saved to the startup config and it needs to be cleared out. Okay. So something to consider. It's not the worst thing in the world, but can potentially produce problems in the future. If you just leave it alone, you enable switch port security, it will go into dynamic secure MAC addresses, which are removed when the switch restarts. So basically, the first MAC address that port learns will be the MAC address that it's limited to using, which is usually a decent situation. If you were to then restart the switch and plug in a different device, then that device would be able to communicate, because this is not saved to the this is not saved to the running config. Okay, so that is maybe the better way to go. Maybe a little bit less secure, but at least if you want to plug in a new device, you don't have to go in and wipe out the previous address and add this one in. Okay, then if you don't, the kind of a combination of these two, if you want to learn the MAC address dynamically, as well as remember that dynamically learned MAC address when the switch reboots, you have this switch port security MAC address sticky, which is going to take any dynamically learned MAC addresses and copy them to the running configuration. Okay, so they're going to stick around if you do a copy run start. So similar to this option up here, only instead of actually typing in the MAC address, it's going to learn that MAC address dynamically and add it to the running config. Okay, it isn't always a situation where you have a limit of one MAC address that's allowed on each port. You can increase that, so maybe not always the biggest issue in the world. But those are your three options that you have presented to you. Okay, so we'll move right along. And when you enable port security, you have different violation modes that can be used. Okay, so the default is shut down, and that means if there are more MAC addresses, or a MAC address tries to access the switch through that port that's above the allowed number, okay, it's just going to go ahead and shut down that port. So no communication is going to go on through that port. All right, it's called an error disabled state that you'll have to go ahead and deal with later on. But if you leave the default port security settings, you're going to be getting this shutdown anytime MAC address above the allowed number tries to access the switch. Okay, so your other options, if you don't want to use shutdown, you can type in switch port security, violation, then the one you want. And like I said, shutdown is the default. You got restrict, which is going to go ahead and block that device from accessing the switch, because you've already got the maximum amount of allowed MAC addresses. And it's also going to create a report letting you know that this device tried to access your hardware. Okay, so restrict is going to block access. It still keeps the port active. Shutdown shuts down the port. Restrict just blocks the access of the the new device that's trying to access your switch port. Okay, and it sends a notification and documents that this device was trying to access the port, basically creating a, I don't know, it's telling on the device essentially. Protect is going to do exactly what restrict does. It's going to protect and not allow that other device to access your port, but it's not going to send a violation report either. Okay, so it's not going to document that some device was trying to access your switch. It's just going to reject the device from access. Okay, so you have three different levels of violations, basically from lowest up here to highest violation. So shutdown, everything's shut down. Restrict, shutdown also creates that report letting you know what device was trying to access your switch as well. So just like restrict, only it goes a step further and shuts it down. Okay, so that is something that will happen as well. So again, you have protect, just denies service. Restrict denies the device and creates a report. Shutdown shuts down the port and creates that report that a device was trying to access your switch. Okay, so those are your three different levels. And again, if you want to switch them, shutdown is the default. You'd go to switch port security, violation, and then the one you want. Okay. So here we have them again. You got protect that doesn't forward the traffic of the new device. It doesn't create a syslog message. It doesn't increase your violation counter, letting you know that there was some violation. It does not shut down a port. Okay, but again, it's not going to forward the traffic from that new device either. Restrict doesn't forward the traffic. It creates a syslog report. Tells on the device by increasing the error violation counter, and doesn't shut down the port. Okay, but this syslog message will tell you what MAC address was trying to access the port, which is unique to restrict. Okay, shutdown doesn't forward the traffic. It does increase the violation counter, letting you know that some device was trying to access your switch, and shuts down the port as well. So things that we discussed on the previous slide. How are you going to set that up? Okay, so a couple of different things you can do. If you only want to set up a port security by its default, and I talked about what the default is. It gives you a maximum amount of MAC addresses at 1. Okay, so only 1 MAC address per port. It is disabled on the port by default. We have to enable it. The violation mode is shut down. Sticky address learning is disabled by default as well on port security. Okay, so port security is not enabled by default. If you just want to enable it with its default values, here's your process down here. Okay, so interface, go to whichever interface you want to apply port security to. Switch port mode access, you basically have switch ports that can be put into access mode or trunk mode. That is something we'll discuss in the next chapter. But you have to make sure the switch port mode is access before you enable switch port security. Okay, then you type in switch port security, which will give you these default values: a maximum number of MAC addresses at 1, violation mode shutdown, sticky address learning disabled. Okay. If you want to tweak things a little bit, there's an example of that over here on the right side. So if you do the same thing, go to the interface, switch port mode access, turn on switch port security, port security. You can increase the maximum number of MAC addresses by typing in switch port security maximum blah. Okay, 10 in this situation. If you want to turn on sticky MAC address learning, then you'd go switch port security, MAC address, sticky. Okay, so that means that any MAC addresses learned will be remembered, will be copied to the running config, and if you copy that running config to startup config, even if you restart the switch, those MAC addresses will still be there in memory. The thing you don't see here is if you want to switch this shutdown violation mode, that command, which we saw in the previous couple slides, that was switch port security violation, then the violation level you want: protect, restrict, or shut down. Okay, so that's really the only thing missing from here. Everything else is there. Also, if you wanted to add a MAC address on your own, you type in switch port security MAC address, and then the MAC address you want to add to that port manually. Okay, so that's all the commands that we have there. We have verifying port security on the next couple slides. So port security verifying, show port security interface, whichever interface you want to see port security on. You can see the violation mode. You can see if port security is enabled, the maximum number of MAC addresses, how many sticky MAC addresses have been learned, and so on and so forth. So that's more for default values. It matches up with our first scenario that we saw down here. Okay. This show port security matches up for this line of commands that we saw. Okay, so you've got maximum MAC address count of 10. You've got sticky MAC addresses. They've learned 1 here. Okay, so far. So that number probably will increase as you plug in more devices to that switch port. Okay, anything else here? Nope, doesn't look like it. Okay. We've got switch port security MAC address sticky. You can see the MAC address that was learned from the sticky command through the running config. So that's all that you're seeing here is a show run the running config. It shows you those commands that were used or commands that could be used to learn these addresses. Okay, so by enabling MAC address sticky, you will see entries like this when you do your show running config. If you had more than one, you'd see more than one here listed. Okay. If you want to see all port security addresses, not just the ones that are in the running config, which would be the sticky addresses or the manually entered ones, okay, the dynamic ones will show up in a show port security address command. So you'll see secure dynamic. This first entry is not in the running config, okay, and it will be forgotten when your switch resets. All right. Ports in error disabled state. So when you have that shutdown violation, you go above the maximum amount of allowed MAC addresses. Your port will go into error disabled. Okay, and you'll be able to see that. So if you do a show interfaces, this is what you'll see: error disabled, port security violation, error detected on such and such port. Putting in error disabled, caused by this MAC address trying to use the port. Its state is down or error disabled. Okay, so know that it is effectively shut down, but how you bring it back up is a little strange. Okay. To continue, if you do a show interface on that port that's disabled, you can see the status is error disabled. Okay. If you do a show port security interface on that interface that's been disabled, you've got all your normal stuff here, but the port status is secure shutdown. Okay, so if you are in this error disabled state, how you bring it back up is you just go to the interface like you normally would. Interface yada yada fast Ethernet 018 in this situation. You're actually going to have to shut down first, okay, to make it go administrative down from its error shutdown or error disabled state, then bring it back up with a no shutdown. You've got to do both, okay, which seems a little odd, and it also seems a little odd that it says shutdown or no shutdown must be issued. It's a and. That should be and no shutdown. So shutdown, then a no shutdown must be done in interface configuration to bring that port back up if it's in an error disabled state. Okay. So, well, that's basically it on securing your ports for MAC address or switch port security. Okay, making sure no unwanted MAC addresses get onto your port. And that is the end of this chapter. So another somewhat light chapter on just a little bit of SSH and switch port security. In the next chapter, we get into VLANs, inter-VLAN routing, trunks, and access ports, and things get really interesting. I think we'll probably split chapter 6 up into 2 different segments because it is quite long. All right, so that's it for chapter 5, and we're done for now.